All right, let's have a look then at question 1c. And this is 1c part 2 of the 2016 NCEA 2 exam for final end of year external. Now, let's have a look. So this is for year 12, and I'm actually looking at this equation, and I'm noticing some huge similarities between this and the previous question. It says, show the solutions that this are 4 times the solutions of that. So when I look at the solutions, this really is going to be a something 7 and a something 8. This one's a something 7 and a something 8. But one of them is 4 times the solution. And it's 4 times the solution because this one here is effectively divided by 4. And I'm looking at this thing here, and I'm thinking this is going to lead us in the same direction. Now, we can't solve it. Well, we actually could solve it in the same way, because we have to find, it says, the solutions of the two. But I think an easier path would just be to use the quadratic formula. So let's go ahead and do that. So I've got my 2 equations. I'm going to write my 2 equations out. So first one is going to be dx squared plus ex plus f, and that's equal to 0. And the second one, I'm going to put a line down the middle here, and write it over here. It's going to be x squared plus ex plus df. All right, and that also equals 0. So let's get the quadratic equation in, which is x is equal to, and I'm going to put x's because we are looking for, after all, the solutions. See how this plays out. So I've got minus b plus or minus b squared minus 4ac all over 2a. I'm going to do the same thing over here. X is equal to minus b plus or minus b squared minus 4ac all over 2. I'm writing them like this so I can see the parallel between the two as they emerge. So let's first of all populate this formula. Or actually, why don't we find or establish the values of a, b, and c first. So the values here of a. So a value here is going to be a d. The b value here is going to be an e. It's the coefficient here. And the c value here is an f. And over here, we've got the a value is going to be a 1. Here it is. The b value is going to be an e. And the c value is going to be a df. Yes, it's the whole thing. So let's see what happens when we populate the quadratic formula now. So I'm going to have minus b, well, b is, so it's minus e. Here it is, plus or minus the square root of b squared, that's going to be e squared, minus 4 times a, which is d, times c, which is f, all over 2 times a, which is d. So that's what my x is equal to, yeah? Here my x is going to equal, same deal, we're going to have minus b, so that's going to be an e, so minus e plus or minus the square root of b squared, that's going to be e squared, minus 4 times a, which is 1, times c, which is df. Now, I'm looking at this and I can see they're exactly the same. It's all over 2 times a, which is going to be 2 times 1. So these two are the same, but for this one is going to be divided by d, which makes this one, right. Okay, so it means that this one here is going to be the solutions. Let's have a look. The solutions of the first equation are d times those of the first equation then. So in order for this equation here to be the same as this one, I would have to multiply this by d in order to get this, yeah? So this one here is d times this equation here. So if I was to multiply all of this by d, sorry, all of this by d. Got to get this right way around. If I multiply all of this times d, I would get this equation here. Yeah, so that's ultimately the solutions. The solutions, right? This one here is going to be d times this one here. So if I multiply all of this by d, I get this one here, which means that this equation is d times this equation. Yeah. Therefore, we could say that this equation here is, if I multiply that by d, I get this one. Yeah. So how are we going to say that? This equation here is d, so put here the second equation. The second equation is d times the first equation. And that's how I would express the answer.